Hello, and welcome to The Sleepy Scientist. Tonight, we're embarking on a slow, soothing journey through time, so far back that even the stars look different, and the continents were just beginning to drift apart like lazy puzzle pieces. This is the story of the dinosaurs, how they rose, how they ruled, and how they eventually, rather dramatically, made their exit. But don't worry, we won't be charging through the Mesozoic like a stampeding herd of Triceratops. No, this is a gentle stroll through ancient worlds designed to help you unwind, rest your mind, and maybe even drift off before we reach the asteroid. Now, I do hope this video isn't too interesting. After all, the goal here is relaxation. But if you find yourself still awake by the time a T-Rex makes its entrance, well, at least you'll come away with some prehistoric trivia to impress your friends. Before we begin, if you find this kind of slow, calming science storytelling helpful, whether it sends you to sleep or just settles your thoughts, consider giving the video a like and subscribing to The Sleepy Scientist. It helps more sleepy souls find their way here. And just out of curiosity, where in the world are you watching from? Let me know in the comments and feel free to share your local time. I love seeing the quiet corners of the world where this channel reaches. Whether it's midnight in Manchester or 2 AM in Tokyo, you're very welcome here. So settle in, maybe you're lying in bed, the lights are low and your pillow is just the right amount of squishy. Take a deep breath, the dinosaurs are waiting. And they've been waiting for about 230 million years. We can take our time. Let's start, not with a bang, but with a silence. The quiet after the end of the world. Roughly 252 million years ago, Earth had just witnessed the worst mass extinction in its entire history. The Great Dying, as it's known, wiped out around 90% of marine species and 70% of land vertebrates. Imagine walking through a forest and hearing nothing. No chirping insects, no rustling underbrush, no croaking amphibians. Just wind through skeletal trees and the distant groan of a reshaping world. If Earth had a reset button, that event was it. The stage was now cleared. From the smouldering ashes of the Permian period, something new was about to stir. But before we meet the dinosaurs, we need to talk about the world they were born into. It wasn't just a different time, it was practically a different planet. The continents hadn't yet scattered across the globe like jigsaw pieces tossed by an impatient toddler. They were all fused into one colossal landmass called Pangaea, surrounded by a single vast ocean, Panthalassa. You could, in theory, walk from what is now New York to New Delhi without getting your feet wet. Just pack plenty of sunscreen. Most of Pangaea was an arid desert, dry and dusty under a scorching sun. The air back then was thinner, the oxygen lower, and the climate wildly unstable. Volcanoes belched gases into the sky, and massive lava flows reshaped the terrain. Plants were tough, scrubby things adapted to drought and heat. But in this harsh environment, evolution began to experiment. One group of reptiles, the archosaurs, began to gain a foothold. The name means ruling reptiles, and it's a good one, because from this lineage would come not only the dinosaurs, but also pterosaurs, crocodilians, and eventually birds. Archosaurs had some impressive upgrades. More upright limbs for efficient walking, stronger lungs, and, in some cases, early signs of warm-bloodedness. While other animals lumbered around like tired lizards, archosaurs were quick, agile, and weirdly well-suited for a post-apocalyptic Earth. Among these early archosaurs was a creature called Eupacaria, a small, nimble predator that darted between the rocks of South Africa. It wasn't a dinosaur, but it gave us a preview. Lightweight, bipedal, fast. The blueprint was forming. Then, around 230 million years ago, in the middle of the Triassic period, true dinosaurs finally appeared. Small ones at first, nothing like the giants we think of today. Picture Eoraptor, a wiry little hunter the size of a dog trotting through fern-filled undergrowth, or Herrerasaurus, with its long jaws and sharp teeth chasing down prey in the dusk. These early dinosaurs didn't roar. They probably hissed or croaked, more like angry birds than monsters. At this point, dinosaurs were underdogs. They shared the land with a host of competitors, other archosaurs, giant amphibians, and strange synapsids, reptile-like ancestors of mammals that looked like something between a Komodo dragon and a badly drawn platypus. It was a crowded, dangerous world. So what helped dinosaurs rise to the top? One advantage was posture. Most reptiles of the time sprawled like lizards, their legs sticking out sideways. Dinosaurs, however, stood tall with legs directly beneath their bodies. This made them faster and more energy efficient. Imagine running a marathon with your knees pointing sideways. Doesn't work so well, does it? Another edge was their respiratory system. Many paleontologists believe early dinosaurs had a type of breathing similar to modern birds, with air sacs that allowed for a constant flow of oxygen. That would have been a superpower in the low-oxygen atmosphere of the Triassic. While other animals wheezed and panted, dinosaurs just kept moving. And let's not underestimate luck. At the end of the Triassic, around 201 million years ago, yet another mass extinction swept across the globe, likely triggered by massive volcanic activity in what's now the Atlantic region. This event decimated the dinosaurs' rivals, especially the large amphibians and many competing archosaurs. With the competition cleared away, the dinosaurs were finally free to expand. From humble beginnings, they were about to become the rulers of the world. But even in their early days, they were diversifying fast. Some stayed small and swift, chasing insects and scuttling prey through ancient undergrowth. Others grew larger and began to experiment with new diets. Plant eaters with small teeth, elongated necks, and the beginnings of the massive forms we'd later associate with the Jurassic. And yes, it's true, many early dinosaurs were likely covered in proto-feathers. Not for flight, but for insulation and perhaps display. It's humbling to think that what began as fuzz to keep them warm in chilly Triassic mornings would, millions of years later, lead to hummingbirds and hawks. Evolution loves to recycle. Despite their growing presence, early dinosaurs still weren't the only game in town. The Triassic landscape was a patchwork of life. Croc-like phytosaurs lurking in swamps, armored etosaurs browsing through foliage, and the occasional giant amphibian doing its best impression of a wet log until something unfortunate walked too close. But the dinosaurs had momentum. Their adaptability, posture, and physiology gave them a crucial edge. And after the Triassic extinction, they seized the opportunity with gusto. In a few million years, they would diversify into an astonishing array of forms, some tall as buildings, others small enough to perch on your finger. Still, here in the late Triassic, they were just beginning. Quietly, persistently, they were laying the groundwork for a reign that would last more than 160 million years. And unlike us, they didn't need smartphones, air conditioning, or espresso to do it. Just good lungs, sturdy legs, and a whole lot of evolutionary determination. So as the Triassic sun sets on the first true dinosaurs, we leave them in a world both strange and familiar. A world where survival is hard-won, but full of potential. They haven't yet grown their horns, plates, or titanic size. But their story is in motion, and the age of dinosaurs is just getting started. When the curtain lifted on the Jurassic period, the Earth looked and sounded different. The world had just weathered another extinction event, one that conveniently knocked out many of the dinosaurs' early competitors. The once crowded Triassic ecosystem was now full of empty ecological real estate, and the dinosaurs were ready to move in. With their upright posture, efficient lungs, and evolutionary momentum, they spread quickly across the supercontinent and began to diversify into an astonishing array of forms. The Jurassic period, which lasted from about 201 to 45 million years ago, was a time of flourishing life, shifting continents, and dinosaur innovation. Earth was warmer and wetter than it had been during the Triassic. Vast inland seas shimmered under bright skies. Lush ferns, towering conifers, and the first flowering plants began to appear, carpeting the land in greenery. With all this plant life came opportunity, especially for the creatures that figured out how to eat it. Enter the sauropods. Sauropods were the long-necked giants of the dinosaur world. Gentle behemoths like Apatosaurus, Diplodocus, and Brachiosaurus. If you've ever seen a dinosaur grazing calmly in a children's book, munching on treetop leaves with a sleepy expression, you're probably picturing a sauropod. These creatures were the giraffes of their time, only significantly more dramatic. Some reached lengths of over 100 feet. That's longer than a blue whale, a tennis court, or most of your local grocery store. How they managed to exist, let alone thrive, is one of evolution's most remarkable tricks. Sauropods had lightweight, hollow bones, which helped reduce the strain of their massive size. Their necks were marvels of biological engineering, with hundreds of vertebrae and an efficient system of air sacs that allowed them to breathe with surprising ease. And while their tiny heads might seem comically small for such massive bodies, they were perfectly adapted to their lifestyle. Scoop, chew, swallow, repeat. Living in herds and roaming across vast floodplains, sauropods could clear entire forests like nature's slow-moving lawnmowers, and they needed to, some estimates suggest they had to eat several hundred pounds of vegetation each day just to keep moving. Imagine the sound of one of these gentle giants walking by, a rhythmic thud of feet, the occasional crunch of foliage, and maybe a low, echoing rumble, something between a whale song and a foghorn. But not all Jurassic dinosaurs were towering plant eaters. With all that sauropod meat wandering around, it was only natural that predators began to level up. Say hello to Allosaurus, a top predator of the Jurassic, and a fine example of the theropod group, the bipedal, mostly carnivorous dinosaurs. Allosaurus was no slouch. We're talking about a creature up to 30 feet long with a skull full of serrated teeth and strong forelimbs tipped with claws that looked like nature's can openers. Its body was built for speed and agility, and it likely used coordinated tactics to hunt larger prey, though whether it was a pack hunter or just really good at ambushing things is still up for debate. In the Jurassic, predation wasn't limited to just brute force. Some theropods began showing signs of more refined traits, lighter bodies, keen senses, and perhaps even early feathers. It's around this time that we find the first solid evidence of a truly groundbreaking innovation in the dinosaur lineage: flight. Meet Archaeopteryx. Discovered in the 19th century and often hailed as the first bird, though technically more of a bird-like dinosaur, Archaeopteryx is one of the most iconic fossils in paleontology. It had feathers, wings, and a wishbone, but also a mouthful of teeth, a long, bony tail, and clawed fingers on its wings. Evolution was clearly in the middle of a design brainstorm. Whether or not Archaeopteryx could fly like a modern bird is still debated, but it probably could at least glide or flutter between trees. More importantly, its existence confirmed something extraordinary, that birds didn't evolve from dinosaurs. They are dinosaurs, every pigeon you've ever side-eyed in a park. A direct descendant of the Mesozoic's most adaptable lineage. But back to the Jurassic world. As continents began to slowly break apart, Pangaea gradually rifting into Laurasia in the north and Gondwana in the south, dinosaur populations became more isolated. This geographic separation set the stage for increased specialization and diversity. In the north, you might find heavily armored stegosaurs like Stegosaurus, with its iconic row of plates down its back and spiked tail. Though it looks like it was built for battle, those plates may have been more about display and temperature regulation than defense, a dinosaur-fashioned statement, if you will. Stegosaurus, it must be said, had a brain about the size of a walnut. But let's not judge, it got along just fine. Intelligence, as it turns out, isn't always the key to survival. Sometimes all you need is a good sense of smell, a tough hide, and the ability to digest enormous quantities of ferns. Jurassic skies, meanwhile, were ruled by pterosaurs, the first vertebrates to master powered flight. Not dinosaurs, but close cousins. These creatures ranged from pigeon-sized flappers to species like Dimorphodon and Rhamphorhynchus, with impressive wingspans and complex behaviors. It's hard to overstate how alien they must have looked. Leathery wings, elongated jaws, and sometimes elaborate head crests. They were like dragons, only more scientifically defensible. And while much of the attention tends to go to the big and flashy dinosaurs, the Jurassic was also home to smaller creatures that played equally important roles. Tiny insect eaters, burrowers, early mammals no bigger than your hand, and fast-moving predators no longer than a house cat. The ecosystem was rich, layered, and full of interactions we can only guess at. One of the lovelier facts about this era is how much evidence we have not just of bones, but of footprints. Fossilized tracks from the Jurassic give us a glimpse into behavior. Herds moving together, predators stalking, young dinosaurs walking beside larger ones. It's a quiet, haunting kind of record, the kind you'd miss if you didn't look closely. Like reading footprints in the sand after the tide has gone out. So the Jurassic wasn't just an age of giants, it was a time of movement, adaptation, and evolutionary experimentation. The earth was warm, the skies busy with flight, the forests echoing with the heavy footfalls of creatures that, to us, seem like legends, but were once very real and very alive. And yet, as successful and widespread as dinosaurs had become, they weren't done changing. Evolution never sits still. In the next phase of their story, they would become even more diverse, more extravagant, and more strangely familiar. But for now, picture the Earth beneath a Jurassic sun, sauropods moving slowly through fern forests, pterosaurs circling over sparkling lagoons, and the distant cry of a theropod echoing across the ancient plains. The age of dinosaurs was well underway, and they were just getting comfortable. By the time the Cretaceous period arrived, about 145 million years ago, the dinosaurs were not just surviving. They were thriving in ways that would make even the most ambitious evolutionary overachievers blush. If the Jurassic had been about growing tall and going big, the Cretaceous was about variety, flair, and specialization. This was the dinosaurs' golden age. They had claimed every continent, filled every niche, and were evolving into forms both spectacular and occasionally downright bizarre. Earth itself was undergoing a dramatic makeover. The single supercontinent of Pangaea had finished breaking apart, and the world now looked more like the one we recognize today, though the coastlines were still messy. North America was split by an inland sea. South America was drifting away from Africa, and shallow tropical oceans lapped across vast stretches of what is now land. The climate was warm, sea levels were high, and new types of vegetation, most notably flowering plants, were just beginning to bloom. Yes, flowers. You might not think of daisies and magnolias as evolutionary game changers, but they were. Before flowering plants, the world was ruled by ferns, cycads, and conifers. These plants were reliable but not exactly high-energy snack material. The arrival of flowers, and the fruits and seeds that came with them, transformed terrestrial ecosystems. They supported new kinds of insects, changed how herbivores ate, and even influenced the evolution of bird and dinosaur species. The Cretaceous was, in many ways, a botanical revolution with teeth. Let's begin with some of the showstoppers of the era, the ceratopsians. This group of dinosaurs includes the likes of Triceratops, Styracosaurus, and Pachyrhinosaurus, creatures that looked like they'd wandered straight out of a medieval jousting match. Massive skulls, ornate frills, and horns in all shapes and combinations. Triceratops alone had a head that could span over 7 feet across, making it one of the largest skulls of any land animal. It wasn't just for look or fancy, though. The frills and horns may have served several purposes: defense, mating displays, and species recognition. Nature loves a multitasker. Ceratopsians were built like tanks, short, stocky limbs, deep chests, and beak-like mouths, perfect for shearing tough vegetation. They likely traveled in herds, and there's evidence of social behavior, including group nesting sites. It's not hard to imagine a procession of Triceratops lumbering across the Cretaceous plains, tails swaying, horns gleaming under a prehistoric sun. And then there were the ankylosaurs, walking fortresses covered in bony armor and bristling with spikes. Some, like Ankylosaurus, even had a heavy club at the end of their tails that could break bones with a single swing. These dinosaurs were so thoroughly defended, it's a wonder anything ever bothered trying to eat them. If a hedgehog were the size of a minivan and had a tail like a medieval flail, you'd get the idea. On the opposite end of the spectrum, we find the duck-billed hadrosaurs. These were the multi-tools of the Cretaceous herbivore world. They had complex dental batteries capable of grinding down tough plant material, up to 1,000 teeth in some species, continuously replaced like conveyor belt molars. Some had elaborate crests on their heads that may have acted as resonating chambers, allowing them to produce low, foghorn-like calls to communicate across long distances. They traveled in herds, raised their young in communal nesting grounds, and were likely among the most socially advanced dinosaurs. But perhaps the most iconic dinosaur of all time also walked the Earth during this period. Yes, the Tyrannosaurus rex, the toothy celebrity of natural history museums and the reason small children can pronounce tyrannosaur before they can spell their own names. T-San. Rex was massive, up to 40 feet long and weighing around 9 tons. Its teeth were banana-sized and serrated, perfect for crushing bone. In fact, T-Rex didn't just eat flesh, it chomped right through skeletons, digesting calcium-rich remains like a walking garbage disposal. There's been debate over the years about whether it was a predator or a scavenger, but the current consensus is, why not both? When you're a 9-ton apex predator, you take the buffet as it comes. Despite its tiny 2-fingered arms, comically short in proportion to its size, T-Rex had an enormous head, powerful legs, and a surprisingly sophisticated sense of smell. Studies suggest its olfactory bulbs were huge, meaning it could probably smell dinner from miles away. Not exactly something you'd want sniffing around your campsite. Yet for all its reputation as a terrifying beast, T-Rex was just one member of a diverse family of theropods that ruled the land in the Cretaceous. Others, like Velociraptor, were smaller, faster, and possibly feathered. And while Velociraptor was not the man-sized menace depicted in certain blockbuster films, it was actually about the size of a turkey, it was still a cunning predator with a sickle-shaped claw on each foot, perfect for slashing prey. Speaking of feathers, the Cretaceous is when they really take off, literally and figuratively. Feathers weren't just a quirky trait anymore, they were becoming increasingly widespread among theropods. Some species had full feather coverings. These weren't always about flight. Feathers also offered insulation, camouflage, and a way to show off. Think of the dinosaur world as a prehistoric fashion show, with elaborate plumage replacing scales in many lineages, and let's not forget the early birds, which by this time had separated themselves clearly from their ground-dwelling ancestors. Creatures like Ichthyornis and Hesperornis filled the skies and coasts, some with strong flight capabilities and others more like aquatic diving birds. With wings, feathers, and beaks replacing toothy jaws, birds were carving out a niche that would ensure their survival long after the dinosaurs were gone. The oceans, meanwhile, were teeming with their own reptilian rulers. Although not dinosaurs, the marine reptiles of the Cretaceous were no less impressive. Mosasaurus, for example, was a giant predatory marine lizard with flippers and a long shark-like tail. It patrolled the warm seas, snacking on fish, turtles, and even other marine reptiles. Then there were the long-necked plesiosaurs, which inspired centuries of sea monster legends, and the ichthyosaurs, whose dolphin-like forms hinted at convergent evolution long before anyone coined the term. All of this, on land, in the air, and under the sea, was part of a rich, dynamic ecosystem where dinosaurs weren't just surviving. They were experimenting, adapting, and thriving. Their world was full of life, color, sound, and movement. From forested river valleys to open plains, from nesting colonies to deep lagoons, the Cretaceous was alive with energy and diversity, and all of it, every feathered raptor, every armored herbivore, every towering carnivore, was powered by the same forces we see today: the slow churn of evolution, the push and pull of ecosystems, and the endless dance of survival. It's humbling, isn't it? To think that a world so ancient could have been so vibrant, so full of story. The Cretaceous wasn't just a prelude to extinction. It was, in many ways, the high point of dinosaur life. A final crescendo before the silence. By now, dinosaurs ruled nearly every corner of the Earth, but it's important to remember they weren't alone. During the Cretaceous period, as dinosaurs flourished on land, a whole array of fascinating life forms were developing alongside them, each with their own part to play in this bustling prehistoric world. From the skies to the seas to the underbrush, the age of dinosaurs was far from a solo act. It was more like a sprawling global performance with an enormous cast of characters, some terrifying, some tiny, some just downright weird. Let's begin with the skies. If you happen to look up on a warm Cretaceous afternoon, you might have seen a creature gliding above with a wingspan longer than a school bus. That would be Quetzalcoatlus, one of the largest pterosaurs ever known. Despite often being lumped together with dinosaurs, pterosaurs were actually close relatives, flying reptiles that branched off from the same archosaur lineage early on. And these weren't just oversized bats flapping aimlessly through the air. Pterosaurs were sophisticated flyers, with hollow bones, powerful flight muscles, and wings made of skin stretched across a long fourth finger. Some soared over coastlines in search of fish, while others stalked inland plains on foot, using their wings like crutches. Yes, that's right. When grounded, these giants folded their wings and walked on all fours, like scaly prehistoric vampires late for an appointment. Pterosaurs came in all shapes and sizes. Some had elaborate crests, like Nyctosaurus, whose head ornament looked like it could double as a sailing mast. The exact purpose of these crests is still debated: display, species recognition, aerodynamic function, but one thing is certain: they turned heads, quite literally. While the pterosaurs owned the skies, Earth's oceans had their own ancient overlords. Take Mosasaurus, for example, a sleek, terrifying marine reptile with a powerful tail and double-hinged jaws packed with conical teeth. It wasn't a dinosaur, but rather a distant relative of modern monitor lizards and snakes. Mosasaurs could grow over 50 feet long and were the apex predators of the late Cretaceous seas. Think of a crocodile, a shark, and a torpedo rolled into one, and then imagine it coming straight at you through crystal-clear prehistoric water. And they weren't alone. There were also plesiosaurs, with long necks and paddle-like limbs, who may have used their flexible necks to snatch fish like an underwater heron. Then there were ichthyosaurs, dolphin-shaped reptiles that were especially dominant earlier in the Mesozoic, though some stragglers survived into the Cretaceous. Fossils show that some gave birth to live young and may have been warm-blooded. Picture sleek swimmers with big eyes, gliding effortlessly through sunlit shallows, dodging predators and chasing prey. Of course, not every Cretaceous creature was a terrifying behemoth. Down at the forest floor, or tucked beneath ferns and flowers, lived a bustling community of small mammals, insects, and birds. Yes, birds. Real, proper birds, many of which had fully functional wings, beaks, and feathers. Species like Ichthyornis looked remarkably like modern seabirds, complete with strong, flapping flight and a gull-like body. Others, like Hesperornis, were flightless diving birds that lived in marine environments. They had beaks filled with small backward curving teeth, a reminder that the avian lineage hadn't quite let go of its reptilian roots. Even more astonishing are the fossil finds that show how birds were experimenting with different lifestyles. Some nested in colonies, others may have migrated seasonally, and all the while their theropod cousins, like Velociraptor and Microraptor, were climbing trees, gliding, and living bird-adjacent lives with feathers of their own. Feathers, by the way, were becoming quite the trend in the late Cretaceous. It's now widely accepted that many theropods, especially those closely related to birds, were feathered to varying degrees. These weren't the great majestic quills of an eagle, but more like soft, downy fuzz, ideal for insulation, display, or both. Some of these dinosaurs likely came in vivid colours, with patterns that might make today's peacocks jealous. Imagine a raptor with electric blue streaks down its back, or a rooster-sized dinosaur flashing red and orange feathers in a territorial showdown. The ancient world wasn't just brown and green, it might have been dazzling. Meanwhile, mammals, those fuzzy nocturnal underdogs, were quietly evolving in the background. Most were still small, resembling shrew-like insectivores, but some were getting adventurous. Fossils from the late Cretaceous show mammals gliding between trees, burrowing into the earth, and even snapping up baby dinosaurs. One famously preserved fossil from China shows a small mammal locked in combat with a dinosaur, each frozen mid-battle in a pose more dramatic than any nature documentary. It's easy to forget just how intricate the web of Cretaceous life was. Every giant had its entourage. Where there were herds of Edmontosaurus, there were parasitic insects buzzing in clouds. Where a predator prowled, scavengers lurked nearby. Small mammals foraged in the shadow of giants. Birds nested on cliff faces, and pterosaurs wheeled silently overhead. And then there were the plants. While they might seem like passive set dressing, Cretaceous flora was undergoing its own revolution. The rise of angiosperms, or flowering plants, marked a major evolutionary leap. Flowers allowed for more efficient pollination, often involving the help of insects, which were also diversifying wildly during this time. Beetles, butterflies, ants, and bees were beginning to appear in recognizable forms, establishing ancient versions of the plant-insect partnerships that continue today. This explosion of plant life changed how herbivores ate, how insects lived, and how ecosystems were structured. With new seeds and fruits on the menu, animals adapted. Some developed specialized teeth and stomachs. Others formed migratory routes to follow seasonal blooms. If you had wandered through a Cretaceous meadow, you might have seen a herd of hadrosaurs grazing among wildflowers, dragonflies zipping above their heads, and small mammals darting underfoot, all of it alive with color, movement, and sound. The Cretaceous wasn't just an age of monsters, it was an age of complexity. Life was experimenting, diversifying, and branching into forms that would echo across time. Some lineages would end, others would persist. The pterosaurs and marine reptiles would vanish, but the birds and mammals would remain. And with them, a tiny, persistent spark of what was to come. In these final million years, evolution was working overtime. The dinosaurs were at their peak, physically, socially, and ecologically. They had spread to every continent, adapted to every climate, and integrated themselves into the fabric of nearly every ecosystem. And yet, even at their most dominant, they were unaware, as life always is, that change was coming. Somewhere out in the cosmos, an asteroid was already on its way, but here in the last golden light of the Cretaceous, life continued. Pterosaurs wheeled across a coral-streaked sky. Hadrosaurs grazed in meadows heavy with pollen. Raptor feet left sharp prints in river mud that would one day harden into stone. And the world, for now, was alive. It began with a light in the sky 66 million years ago, somewhere above what is now the Yucatan Peninsula in Mexico. A chunk of rock, roughly 10 kilometers wide, about the size of Mount Everest flipped sideways, hurtled toward Earth at a speed of over 60,000 kilometers per hour. To say it arrived quickly would be an understatement. One moment the skies were calm, the next, the world was forever changed. This was the Chicxulub asteroid, and its impact would bring about the fifth major mass extinction in Earth's history. The result? The end of the reign of non-avian dinosaurs, and the beginning of a very different world. Let's take a moment to appreciate the sheer violence of the event, though we'll do it gently. This is the Sleepy Scientist, after all. When the asteroid struck, it didn't just create a crater, it created chaos. The impact released energy equivalent to billions of atomic bombs. The ground liquefied, shockwaves raced around the planet. Forests caught fire hundreds, even thousands of miles away. If you'd been anywhere nearby, you would not have seen much, just a blinding flash, and then nothing. But the true devastation came not from the immediate explosion, but from what followed. The heat generated by the impact sent trillions of tons of vaporized rock and sulfur into the atmosphere. Globally, this formed a dense sun-blocking layer that plunged the planet into darkness. Photosynthesis ground to a halt, plants withered, food chains began to collapse, global temperatures dropped drastically in what some scientists describe as a nuclear winter scenario. Fires raged, then darkness fell, the skies rained acid, the seas turned toxic, and over weeks, months, and years, the finely balanced ecosystems that had supported dinosaurs for over 160 million years unraveled. For large herbivores like Triceratops and Edmontosaurus, the collapse of plant life meant starvation. For predators like Tyrannosaurus rex, it meant the disappearance of prey. It wasn't a sudden cinematic collapse where one day dinosaurs roamed and the next they were gone. It was a drawn-out decline, with populations dwindling, habitats fragmenting, and survival becoming increasingly difficult. Only creatures small, versatile, or extraordinarily lucky stood a chance. Among the survivors were some of the smallest members of the dinosaur lineage, the birds. Thanks to their small size, fast reproduction rates, and varied diets, certain avian species squeaked through the extinction bottleneck. They would eventually diversify and fill many of the ecological niches left behind, from the hummingbird to the ostrich. Other winners in this terrible lottery included small mammals, amphibians, certain reptiles, and ocean-dwelling creatures like sharks and some species of fish. Being small, burrowed underground, or able to survive on detritus proved to be a winning formula. Size, it seems, was not an advantage during an extinction event. T-Rex may have had a bone-crushing bite, but it couldn't outlast a cold, dark world with no food. One of the most fascinating elements of the extinction is how uneven it was. Not all environments were hit equally. Some parts of the world may have retained patches of green for a time. Some ecosystems may have bounced back faster. But globally, it's estimated that around 75% of all species went extinct. The oceans too were devastated. Plankton, those microscopic floating photosynthesizers that form the base of the marine food web, died off in huge numbers when sunlight disappeared. Coral reefs collapsed. Marine reptiles like mosasaurs and plesiosaurs vanished. Giant ammonites, the spiraled mollusks that had thrived for hundreds of millions of years, disappeared forever. The loss of biodiversity was immense, but in nature endings often pave the way for new beginnings. With the dominant species gone, the survivors inherited a quiet, empty world. For millions of years, Earth was in recovery mode. Slowly, as the skies cleared and sunlight returned, life began to re-establish itself. Plants took root, forests returned, insects buzzed, and the mammals, tiny, scrappy, and warm-blooded, began to expand into new niches. But the question often asked is, why didn't the dinosaurs survive? Well, to be precise, some did. Every bird you've ever seen is a dinosaur, descended from feathered theropods that lived alongside T-Rex. But when people ask this question, they usually mean the large ground-dwelling dinosaurs. Why didn't they make it? It comes down to a combination of factors. First, size. Large animals require large amounts of food, and with the plant life gone, there simply wasn't enough energy in the system to sustain them. Second, reproduction. Dinosaurs laid eggs and took time to mature. Mammals, by contrast, could birth live young, feed them with milk, and reproduce more quickly. In a rapidly changing environment, speed matters. And third, luck. Evolution is never a guarantee of survival. It's not the strongest to endure, but the most adaptable. The asteroid wasn't a judgment, it was a cosmic accident. The dinosaurs didn't fail, they just faced odds no creature could overcome. What's even more humbling is how long they thrived before this event. From the dawn of the Triassic to the end of the Cretaceous, non-avian dinosaurs ruled Earth for over 160 million years. That's longer than mammals have existed, longer than flowers, longer than birds had wings, and during that time they didn't stagnate. They evolved, diversified, and adapted to nearly every environment, from Arctic forests to desert dunes, from swampy deltas to high plains. They ran, climbed, swam, and soared. They left footprints in the mud and feathers in the silt. They built nests, cared for their young, and in at least one lineage learned to fly. Their story didn't end because they were flawed. It ended because sometimes the universe throws a curveball you just can't dodge. And even then, they didn't entirely disappear. Birds carry their legacy in their bones, in their feathers, in the way they lay eggs and build nests. Every time a crow caws or a sparrow hops across a sidewalk, you're seeing the flicker of a world long gone. Even in extinction, dinosaurs continue to fascinate us. They've captured our imaginations for centuries. We've painted them on cave walls, studied their bones, built them into myths, movies, and museum halls. We've made them heroes, villains, pets, monsters, and even punchlines. But before all of that, before the books and blockbusters, dinosaurs were simply animals, living their lives across millions of mornings and evenings, eating, sleeping, hunting, hiding, thriving. And their ending, as dramatic as it was, is only part of their story. In a way, they're still here. Not just in birds or bones or the books on your shelf, but in our collective imagination, where they still walk the earth, under ancient skies, in a world forever alive in our dreams. If dinosaurs were Earth's most spectacular tenants, then evolution was the master architect behind their success. For over 160 million years, these creatures adapted, innovated, and diversified in ways that still astonish scientists today. But what made them so remarkably successful? Why did they dominate while other lineages faded quietly into the background? To understand the staying power of dinosaurs, we have to look beyond their size or teeth. It wasn't just brute force or flashy horns that gave them an edge. It was biology, behavior, and an uncanny ability to adapt to a changing world. Let's start with a surprisingly important upgrade: posture. Most reptiles before the dinosaurs moved with limbs splayed out to the side like a lizard dragging its belly across the ground. Dinosaurs, however, evolved an erect, pillar-like stance with legs directly beneath their bodies. This posture wasn't just a fashion choice, it made them more efficient walkers and runners. With their center of gravity better aligned, dinosaurs could move more quickly and for longer distances without tiring. It was an evolutionary leap forward in energy management, especially for large, mobile herbivores. This upright posture also allowed for greater size. You can't be 80 tons and drag your belly along the ground. It's just not a winning strategy. Sauropods, for instance, could stretch skyward, grazing from the treetops because their skeletons and muscles were aligned to support enormous frames. Some species, like Argentinosaurus, may have tipped the scales at over 100 tons, equivalent to more than 15 African elephants combined. But posture was just the start. Dinosaurs also had unique respiratory systems. Many paleontologists believe they used a system similar to modern birds, involving air sacs connected to the lungs. Unlike mammals, which breathe in and out with each breath, birds, and likely dinosaurs, had a unidirectional flow of air, allowing for constant oxygen exchange. This made them incredibly efficient breathers, important in the low oxygen environments of the Triassic and Jurassic periods. Think of it this way: while other animals were wheezing up hills, dinosaurs were powering ahead with lungs that worked like biological turbochargers. This respiratory system also helped regulate body temperature, possibly contributing to another dinosaurian advantage: warm-bloodedness. The debate over whether dinosaurs were cold-blooded like modern reptiles or warm-blooded like birds and mammals is ongoing, but the current consensus leans towards something in between, or perhaps even closer to warm-blooded. Many theropods show signs of fast growth, high activity levels, and complex behaviors that align with a metabolically active lifestyle. Warm-blooded animals can operate in a wider range of environments and times of day. This may have allowed dinosaurs to be nocturnal, to live in polar regions, and to keep active in cooler climates, where other reptiles would have slowed to a crawl. Then there's reproduction. Dinosaurs, despite their size, laid eggs, a reproductive strategy that allowed them to create many offspring at once. Some species, like hadrosaurs, built large communal nesting grounds and may have cared for their young. Fossilized nests, eggs, and even embryos show that these weren't mindless beasts dropping eggs and wandering off. In some cases, adults remained with their nests, guarding them from predators and perhaps even feeding hatchlings or leading them in herds. There's something deeply moving about that. Picture a massive Maiasaura. Its name means good mother lizard, tending carefully to its nest, nudging eggs with its beak, watching over a creche of squawking hatchlings. These moments, frozen in fossil beds, speak to a social intelligence we're only just beginning to understand. Speaking of intelligence, yes, some dinosaurs were quite clever. Theropods, especially members of the Dromaeosaur family, like Velociraptor, had relatively large brains for their body size. They may have hunted in packs, coordinated ambushes, or used problem-solving skills to find food and avoid danger. Their eyes faced forward, suggesting depth perception and advanced vision. And while they weren't writing poetry or designing tools, they weren't lumbering brutes either. Birds, their direct descendants, inherited much of this cleverness. Modern crows and parrots are famously intelligent, capable of using tools, solving puzzles, and even playing tricks. That lineage of intelligence didn't begin with the parrot at your bird feeder. It began with sharp-eyed theropods tens of millions of years ago. Let's not forget diversity. Dinosaurs weren't a monolithic group. They came in an astonishing variety of forms, from chicken-sized insectivores to titanic plant-eaters. Some had armor, others had horns, sails, claws, or feathers. Some walked on 2 legs, others on 4, and some switched depending on the situation. They filled every niche: fast grazers, stealthy predators, long-distance wanderers, swamp dwellers, desert trotters. Their ability to specialize meant they could adapt to a wide range of habitats, diets, and climates. When the environment shifted, they shifted with it. Some species lived in the tropics, others in what is now Antarctica. Fossilized remains have been found on every continent, including Antarctica, evidence that some dinosaurs could handle the cold, perhaps aided by their feathers or warm-blooded physiology. Another secret to their success? Time. Dinosaurs weren't rushing through history. They had tens of millions of years to evolve, to test ideas, to fail and try again. That kind of evolutionary patience is hard for us to grasp. Human civilization is barely a blink compared to the time dinosaurs reigned. We've built cities, satellites, and streaming services in just a few thousand years. Dinosaurs had entire eras to experiment with different designs, behaviors, and ecosystems, and throughout it all, they left behind clues: bones, teeth, footprints, skin impressions, and even fossilized feathers. These remnants let us piece together their story like a prehistoric jigsaw puzzle. One particularly fascinating clue comes in the form of trackways, fossilized footprints that show movement, behavior, and social interactions. Some show herds moving together, juveniles walking beside adults. Others show predators stalking prey. One trackway in China even shows a raptor-like dinosaur dragging its claw in the dirt, perhaps bored or distracted or just stretching its foot, a fleeting moment frozen forever. In the end, it wasn't just sharp teeth or long necks that made dinosaurs great. It was their adaptability, their diversity, and their resilience. They weathered mass extinctions, survived dramatic climate changes, and evolved into a bewildering array of forms. And perhaps their most astonishing accomplishment: they never truly went extinct. Birds are still here. Every wing beat, every chirp, every carefully woven nest is a continuation of the dinosaur story. The same lungs, the same bones, the same DNA blueprint, just reshaped and reimagined by evolution. So the next time you see a pigeon pecking at a chip or hear a songbird greet the morning, remember, you're looking at a survivor, a living fossil, a distant cousin of Velociraptor, just with fluffier feathers and slightly less attitude. Dinosaurs weren't a failed experiment. They were one of nature's greatest success stories. And though most of them are gone, their legacy still soars above us, chirps from tree branches, and pecks curiously at cafes' crumbs. They were, and still are, magnificent. Even after all these millions of years, dinosaurs remain one of the most captivating mysteries nature ever wrote in stone. Their bones lie silent beneath our feet, but we are still uncovering their secrets, bit by bit, layer by layer, with the quiet persistence of curious minds and muddy boots. And that's where the next chapter of the dinosaur story comes in: paleontology, the science of piecing together the past from the remnants it left behind. It's easy to imagine dinosaurs as creatures of the past, long gone, dusted off and wrapped up neatly in museum displays. But the truth is, we are still in the early days of truly understanding them. Every year, new species are discovered, old assumptions are overturned, and fresh insights change the way we picture life in the Mesozoic, and it all begins with the rocks. Dinosaur fossils form under very specific conditions. When a dinosaur died, say in a riverbed or a floodplain, it had to be quickly buried by sediment, mud, sand, volcanic ash. Over time, as more layers accumulated and pressure increased, the organic material would slowly be replaced by minerals. What remained, sometimes millions of years later, was a fossil, an imprint of ancient life preserved in stone. But finding fossils, that's a different challenge entirely. Most of the Earth's surface is covered with thick vegetation, cities, oceans, or modern life in general. The tiny percentage of exposed rock from the right time period is where paleontologists focus their efforts, often in deserts, badlands, or windswept cliffs. Think Montana, Mongolia, Argentina, and China, places where time has peeled back just enough layers for us to peek underneath. And even then, fossils are rarely discovered fully formed like a museum diorama. More often it's a single fragment, a knobby bone peeking from a dusty slope, or a curious texture in a cliff face. It takes trained eyes to notice, patient hands to extract, and years of research to understand. Once uncovered, fossils are meticulously mapped, catalogued, wrapped in protective plaster jackets and transported, often over thousands of miles, to labs and universities. There, paleontologists clean them with brushes and dental tools, examine them with CT scans and microscopes, and compare them to existing specimens. It's part science, part detective work, and part extreme jigsaw puzzle. And sometimes it leads to spectacular surprises. Take the discovery of Dinosaurs, for example. For decades, all scientists had of this mysterious creature were two enormous clawed arms, each longer than a grown man, with no skull, no body, and very little context. The imagination ran wild. Was it a predator? A giant slasher lizard? A Mesozoic nightmare? Then in 2014, more complete specimens were found. And the real animal? Even stranger. Dinosaurs was a humpbacked, pot-bellied, duck-billed omnivore with a shaggy coat of feathers and a face like a shoebill stalk. It looked like someone hit randomize on a dinosaur design generator, and yet it was real. These moments of revelation remind us how much we don't know. Our mental image of dinosaurs has evolved dramatically in recent decades, shaped by science, not cinema. Gone are the drab, tail-dragging reptiles of the 1950s. In their place are dynamic, colourful social animals, many feathered, some vocal, and some even nesting or herding, like modern birds and mammals. The shift began with the so-called dinosaur renaissance in the 1960s and 70s. Paleontologist John H. Ostrom re-examined a small theropod called Deinonychus and noted its bird-like hips, claws, and posture. It wasn't a slow, cold-blooded lizard. It was agile, active, and intelligent. This reimagining laid the groundwork for the idea that birds are living dinosaurs, an idea now widely accepted in science. Further research into bone structure, growth rates, nesting behavior, and even fossilized soft tissues has continued to flesh out the picture. Yes, you read that right, soft tissues. In recent years, scientists have found traces of collagen, blood vessels, and even pigment cells in exceptionally well-preserved dinosaur fossils. From these, we're beginning to understand not just the shape of these animals, but their color. Imagine a microraptor, a four-winged, feathered dinosaur gliding between trees with glossy, iridescent plumage, or a psittacosaurus with a striped tail and a patch of dark scales across its shoulders. These aren't just bones, they are beings with patterns, behaviors, and perhaps even personalities. And the tools we use to study them are getting more sophisticated by the day. CT scanning lets researchers peer inside fossilized skulls to reconstruct brain shapes and sensory capabilities. Chemical analyses can detect the trace elements left behind by feathers or skin. Computer modeling helps simulate muscle movement and body mechanics. We can even model how a dinosaur breathed, ran, or bit into its prey, all without moving a single bone. Then there's the study of ecosystems. Fossils rarely appear alone. In many sites, you find entire communities preserved: plants, insects, fish, reptiles, and mammals. By analyzing the pollen, soil layers, and even isotopes in fossilized teeth, scientists can reconstruct entire prehistoric environments. How much rainfall there was, what the temperature felt like, and what kinds of food were available. It's a little like time travel, but instead of stepping into a machine, we step into a field site with a notebook, a pickaxe, and a microscope. Fossils also tell us how dinosaurs lived and died. Bone beds, areas with dozens or hundreds of fossils, sometimes suggest mass deaths from floods, droughts, or volcanic events. Pathologies in bones show injuries, infections, or healed wounds. A T-Rex with a healed broken leg suggests not just injury, but survival, perhaps even support from a group. And perhaps the most touching fossils are those that capture motion: footprints frozen in mud, nests filled with eggs, or a mother curled around her young. In one fossil from Mongolia, a small theropod is preserved with its wings outstretched, shielding its clutch of eggs from a sandstorm that buried them both. A 70-million-year-old moment of care caught forever. These discoveries connect us not just to what dinosaurs were, but to what they were like. They weren't distant alien creatures. They were animals. They nested. They fought. They grew old. Some sang, some strutted, some soared, and they inspire us still. Paleontology isn't just about bones. It's about imagination, inquiry, and wonder. It asks us to picture a world utterly different from our own, then dares us to find the evidence that it really existed. And every time a fossil is pulled from the earth, it's like unearthing a sentence in an ancient book, a fragment of a story that's still being written. Because the study of dinosaurs isn't finished. Not even close. There are thousands of species yet to be discovered. Entire groups remain mysteries. Even well-known species like Triceratops or Stegosaurus still hold secrets in their skeletons, and every fossil, every rib, tooth, or claw whispers the same quiet truth. The past is never truly gone. It's all around us, waiting patiently beneath our feet, in the rocks, in the hills, in the gentle press of time. And perhaps somewhere out there, the next velociraptor, or the next unknown wonder, is resting quietly beneath a thin layer of stone, waiting for sunlight, for careful fingers, and for the simple magic of being seen again. When you think of dinosaurs today, chances are the image in your mind has been shaped more by cinema than science. Thunderous T-Rex roars, menacing raptors, and improbable battles between beasts that never actually met in real life. All thrilling, all dramatic, and mostly quite wrong. But let's not be too harsh on Hollywood. After all, these prehistoric titans have fired our imaginations for centuries. The truth is, dinosaurs have left an astonishing legacy, not just in bones or birds, but in our culture, our art, and even our dreams. It began long before the term dinosaur existed. Ancient people uncovered fossils long before they knew what they were. Massive bones unearthed from cliffs and hillsides were often interpreted through myth. In China, they were thought to be the remains of dragons. In parts of Europe, they were linked to giants or beasts from folklore. Even in North America, indigenous peoples had stories of thunderbirds and earth monsters that may have been inspired by fossil finds. It wasn't until the early 19th century that we began to give these creatures scientific names. The word dinosaur itself, meaning terrible lizard, was coined in 1842 by British paleontologist Sir Richard Owen. The name stuck, even though we now know dinosaurs weren't lizards at all, and not all of them were particularly terrible. Still, it had a certain flair to it, and from that moment on, dinosaurs became a permanent fixture in the human imagination. Museums played a huge role in this. The late 1800s and early 1900s saw a boom in fossil hunting, especially in the American West. This was the era of the so-called Bone Wars, a fierce and sometimes petty rivalry between two scientists, Othniel Charles Marsh and Edward Drinker Cope, who competed to discover and name as many dinosaurs as possible. Their race led to over 40 new species being described, including some of the most iconic, Stegosaurus, Apatosaurus, and Allosaurus among them. Museums around the world began displaying massive fossil skeletons, drawing crowds of visitors who marveled at these ancient creatures frozen in mid-stride. For many children, and more than a few adults, seeing a T-Rex or a Diplodocus in person was a defining moment. It connected us, however briefly, to a world long gone. Then came the movies. Dinosaurs marched into popular culture in the early 20th century with films like The Lost World, 1925, which featured stop-motion dinosaurs roaming a forgotten plateau. But the real cultural shift happened in 1993, when Jurassic Park roared onto screens with CGI dinosaurs so lifelike, they made audiences gasp. Suddenly, dinosaurs weren't museum relics. They were alive. They were fast, smart, dangerous. Of course, science has moved on quite a bit since then. We now know that Velociraptor was feathered and about the size of a turkey. T-Rex probably didn't roar like a lion, it might have rumbled more like a crocodile. And many of the dinosaur face-offs imagined in the movies are pure fiction, with creatures from different time periods or continents squaring off like boxers in a ring. But that's okay, because for many people those movies sparked a lifelong interest in paleontology. They turned fossils into celebrities. They reminded us that the world is much older, stranger, and more fascinating than we often remember. Dinosaurs have crept into every corner of culture. They appear in cartoons, video games, books, toys, and breakfast cereals. Children seem naturally drawn to them, rattling off names like Ankylosaurus and Pachycephalosaurus with a level of fluency that baffles many adults. There's something irresistible about these creatures, part alien, part familiar. They're big but not unknowable, ancient but vividly imagined. And perhaps that's because dinosaurs tap into something deep in the human psyche, a love of mystery. They remind us that the Earth was not always as it is now, that oceans once lapped against the Rockies, that forests once covered Antarctica, that giants once walked where we now drive to work or buy groceries. But the legacy of dinosaurs isn't just confined to entertainment. They've inspired art, literature, and even scientific innovation. Consider biomimicry, scientists studying dinosaur anatomy to design better robots, prosthetics, or even spacesuits. Consider architecture. Some buildings and bridges mimic the lightweight yet strong-bone structures of sauropods. Even in medicine, studies of dinosaur metabolism have informed our understanding of thermoregulation and growth rates in modern animals. And of course, dinosaurs continue to shape science itself. The study of dinosaurs is one of the best public gateways into the world of evolutionary biology, geology, and deep time. Learning about them naturally leads to questions about how the Earth formed, how species change, and how ecosystems collapse and recover. Dinosaurs make science personal, tangible. You can see their bones. You can hold a fossil in your hand and feel quite literally the weight of history. Even in language, dinosaurs have left their mark. We use the term metaphorically, sometimes affectionately, sometimes not. A dinosaur might refer to an old-fashioned company or a reluctant-to-change manager. It's a little ironic, considering how successful and adaptive dinosaurs actually were. If lasting 160 million years makes you obsolete, then the rest of us are barely a blip. But perhaps the most profound legacy dinosaurs leave behind is perspective. They remind us of the vastness of time, of how small our own moment is. Dinosaurs were here for far longer than humans have existed. They survived multiple extinction events. They flourished on every continent, and then, in an instant, they were gone, wiped out by forces they never saw coming. And yet life continued, changed, but undeterred. That story, the rise, the fall, the transformation, isn't just a prehistoric tale. It's a mirror, a reminder that extinction is part of life's rhythm, that no species, however mighty, is immune to change. That resilience, adaptability, and curiosity are the real keys to longevity. And in that way, dinosaurs are still teaching us about survival, about legacy, about our place in the grand, strange, beautiful story of Earth. Because they're not just bones in the dirt. They're whispers from a deeper time, shadows of ancient sunlight, echoes of thunder on a primeval plain. And if you listen carefully, in the rustle of leaves or the call of a bird, you might just hear the distant heartbeat of that ancient world. Still pulsing, still with us, still alive. And so here we are, millions of years, thousands of species, and one asteroid later, at the quiet end of a long and extraordinary tale. From humble beginnings in the shadow of extinction, to colossal dominance across continents, and finally to their transformation into the birds that flutter outside your window, dinosaurs were never just ancient creatures of the past. They were innovators, survivors, and architects of entire ecosystems. And though most are gone, their story still lingers in the rocks beneath our feet, the wings above our heads, and the wonder in our imaginations. They remind us that the Earth is ancient, ever-changing, and full of surprises, that survival isn't always about strength or size, but adaptability, resilience, and a bit of luck, and that sometimes even the mightiest beings leave behind whispers rather than roars. So as your eyes grow heavy and your thoughts begin to drift, let that story settle in. Let the rustle of ferns, the distant cry of a feathered raptor, and the gentle thud of ancient footsteps accompany you into sleep. Dinosaurs walked this Earth for over 160 million years, and in many ways they're still walking with us now in birdsong and fossils and in our ever-curious minds. Before you drift off completely, I'd love to ask again, where in the world are you listening from tonight? And what time is it where you are right now? Whether it's the early hours in Edinburgh or a midnight breeze in Melbourne, I'm glad you're here. If you enjoyed this quiet journey through time and would like to hear more stories like this, consider leaving a like and subscribing to The Sleepy Scientist. It helps others find their way here, too. I am. Sleep well and dream of distant worlds.